Hello, good morning, good afternoon, good evening, everyone. How's it going? Welcome, Raphael. Welcome, Akansha. How are you both doing today?
Hi. Good, good. How are you?
Akansha's muted, but that's okay. This normally happens.
Yeah, I'm all good. Thanks.
Fantastic. Well, I'm excited to have Raphael here to talk about eBPF and runtime security and Tetragon. And one of the reasons why we decided to do this particular session today was because we've spent a lot of time going into Cilium and what it does from a networking standpoint, and even what it does for Kubernetes. And I think it's also worthwhile understanding the extensions of Cilium and that networking, and even where eBPF shines in different areas. And so, Raphael, I want you to maybe introduce yourself. Tell us a little bit about, what you've been up to, a little bit about your history and how you got into the world of eBPF and runtime security. Maybe even explain what eBPF is if you've got a few moments here to spare.
All right. So yeah, my name is Raphaël Pinson, and I'm currently working as a technical marketing engineer at Isovalent. I joined Isovalent a little bit over 2 years ago, originally as a solutions architect, but I really enjoyed starting to write labs for Cilium and Tetragon and so on. And as this was like pretty much becoming my main activity, it made more sense to move to the the marketing side to do this kind of stuff. So I really enjoy like sharing about different topics. So public speaking, but yeah, building labs is really something I definitely enjoy. So I fell into BPF, I think via Cilium and via joining Isovalent. And the more I learn, the more I find wow, there's really a lot of things that can be done this way that can revolutionize both like networking on the side of Cilium, but also security on the side of Tetragon and many other tools, both like to gather information, but also to enforce things directly in the kernel. So yeah. What is eBPF? You wanted to talk about
Yeah,
this a
let's
bit.
go. Tell us.
Uh, I like to say a lot of people already use eBPF. Like if you have an Android phone, for example, and you're looking at which applications are using the bandwidth on your phone, you're typically using eBPF because this is not something that the kernel has. This is not information that is provided by default, right? So you need to extend the kernel in order to have that kind of information, that kind of metadata, which process has been doing this network requests. You need eBPF to get this kind of information. But in the scope of cloud native, it's even more obvious because very often we care not only about the process but about metadata that is linked to like the container or even the pod in Kubernetes. And so it makes a lot of sense that we want to attach metadata to the events that we are observing. And if you don't use eBPF, then you need to get information from the OS and then correlate this with the metadata in user space. And this is pretty costly, especially if you have a lot of events you want to observe. So with eBPF, we're actually able to inject the metadata in the kernel so that when we observe the data, when we observe the events that are happening, and it could be processes starting, it could be processes stopping, it could be access to the network, it could be changes in Linux namespace capabilities, you name it, reading and writing files and so on. Then you can, in the kernel, you can actually attach the metadata that you care about. So the pod names, the Kubernetes namespaces and all this stuff. And one great thing that Tetragon does is that you can actually correlate this stuff in the kernel. You can aggregate in the kernel, because what's really costly is actually getting the information out of the kernel into user space and turning it into JSON logs, Prometheus metrics, and so on. So Tetragon can do this, but because it can already do the correlation and the aggregation in the kernel, then there's far less information to extradite out of the kernel into user space. So it's much more performant this way. And then there's a whole enforcement as well, where you can actually program the kernel to enforce rules, to enforce security rules without going through user space. So a lot of tooling will traditionally go through user space, observe things, and then if there's something you don't like, then in user space you will decide to kill the process, but it's too late most of the time because things can have happened in the kernel while you were observing and deciding to do something. Whereas with Tetragon, we can actually program the kernel to say, if this happens, then kill the process, or even respond to the syscall in a different way, So you can be extremely reactive. You can actually prevent a syscall from happening.
So let's back up a bit, and maybe there's a lot going on there, right? So I kind of want to maybe reaffirm my own understanding of eBPF. So I've got access to the kernel, and I'm looking for events, syscalls, anything that might be going on in that space. And when that event occurs, I want to be able to do something based off of that event. But this is happening at the kernel space. Now, I can write programs that are sandboxed that don't break or destroy or crash the kernel, that are verified, but it's still able to receive data from let's say that event, and then store it in some sort of map or buffer or something of sorts. And then on the user space side, we're able to take that information and relay it back to an end user. Is basically how eBPF is working.
Yeah. So basically, eBPF allows to extend the kernel to react to events using triggers, using hooks. So when these events happen, you will execute your eBPF program. And this can be used to observe, but it can also be used to modify the way the kernel works. So a lot of tools use eBPF just to collect data and then send it to user space. This is what Falco does, for example. And this is already progress compared to using a kernel module to do this. But tools like Tetragon go a bit further than this, because instead of just getting information with eBPF from the kernel and then sending it to user space for treatment, it tries to do as much as possible in the kernel itself to be more reactive and closer to the event that happens.
And that's important too, especially when we're talking about network traffic. We want to be able to intercept and intervene in kernel space versus user space just because of that speed. Now, Cilium is a perfect example of where this is being used. Let me ask you a question, right? So why would I not just like recompile my kernel all the time? What's the challenge with doing that with these additional features?
That's a good question. I mean, first, if you wanted to code this logic into the kernel, you would need to add code to the kernel itself or use kernel modules. And one big issue with this is stability and security, right? Because you're extending the kernel with access to pretty much anything you can do in the kernel. You can manage memory yourself and so on. You're very likely to actually introduce more security issues or more instability in the kernel by doing so. Whereas eBPF gives you a system, a subsystem of the kernel that actually verifies the program when you inject them and makes sure that they won't crash the system and that they're quite secure. You're pretty limited with eBPF in what you can actually do. It will prevent you from doing a lot of things. I remember, I think when I started learning about eBPF, one kernel developer told me that one of their goal was really trying to convince the kernel that they didn't mean any harm, and that this was quite a bit of work to actually get their program accepted by the kernel.
That's awesome, man. Honestly, the way you just relayed how eBPF is functioning, and some of the considerations on why kernel recompilation is not the right way, and it's better to write these sandbox programs in eBPF is the right way. Now, for a developer, what are some of the languages that they should know to be able to write eBPF based programs?
I think it really depends on the developers. I think most developers will never write an eBPF program.
So then they're going to write something in user space then, and then that, I guess, connects to something in the kernel.
Yeah, I mean, what I find really fascinating is that for a long time, I mean, eBPF has been used for a pretty long time in the industry, but for a long time, you pretty much needed a kernel team to take advantage of it. So it was companies like Facebook, like Netflix, like Google, and so on that took advantage of eBPF because they had kernel developers who could write the eBPF code for their needs, to write a load balancer, to write programs to protect from DDoS attacks, things like this. And now with the new projects that are emerging, especially in the CNCF ecosystem, there's programs, there's user space programs that can be Tetragon, that can be Cilium, that can be Falco, and so on. And this program come with templates of already written eBPF programs that they can inject in the kernel. And I like to say Tetragon is actually pretty much an eBPF framework in a way. in that it's not eBPF framework. It's a framework that allows people that don't know about kernel programming to actually create programs that will be injected into a kernel for security, visibility, and enforcement. So it provides like an API in the form of the Kubernetes CRDs. And with this API, it will generate the eBPF programs and inject them. And you don't need to know how this works. You don't need to know kernel programming yourself. So usually, if you were to do the kernel programming yourself, you would use C or a subset of C. There's people that use Rust as well. I know there's a way to write in Rust, but most people really will rely on tools that already provide the boilerplate pretty much of the programs that do generate stuff in the kernel.
That's fantastic. For the folks that are listening in or watching in either on Twitter, X, LinkedIn, or YouTube, if you've got questions, we've got an expert. We've got an eBPF expert right here. Feel free to buzz away. We'll be happy to help and answer your questions. Now, I think it'd be really cool if we could dig into how we use some of this eBPF magic in the sense of runtime security. So, Raphaël, why don't you tell us a little bit about some of the labs that are available, and maybe Akansha, if you want to share your screen, we could probably hop in there.
Sure. So, yeah, we've been having quite a lot of fun writing quite a few labs. A lot of them are about Cilium. We have a few about Tetragon. I'm actually aiming to write more in the future. And so this one is the Getting Started with Tetragon. It is based on a book that was originally written by Natalia Ivanko, who works with us, and Jed Salazar, who used to work at Isovalent and is now at ChainGuard. And the book is still available. You can find it on our website, actually. And based on this book and the examples they gave, which was like early Tetragon, I think the book was written when Tetragon wasn't called Tetragon. It was an Isovalent enterprise at the time. And so this shows how you can detect a typical attack using Tetragon. And I just added this morning a new challenge at the end, just before the exam, that shows how you can enforce security rules using Tetragon.
Nice. All right, let's kick it off.
All right, it takes a few minutes to start. I think, yeah, more or less a minute. There's some nodes. Yeah, if you go here.
So what, while this is loading up, what are some of the other labs that folks can take if they went over to your website?
Well, there's a lot of Cilium labs that cover a lot of different things. That can be so what we did, and what I recommend starting usually, is what we did for Chicago 6 months ago. We added 3 labs that we call Discovery Labs. And these Discovery Labs are tailored by profile. So there's a Cloud Network Engineer lab, there's a SecOps lab, and there's a Platform Engineer lab. So the cloud networking is obviously, networking, so it has like BGP, IPv6, all this kind of stuff. The platform one is more like layer 7 from the point of Cilium. So it'd be like Ingress, Gateway API, this kind of things that is more like geared towards platform people network-wise. And the SecOps one actually touches on Tetragon, network policies, mutual authentication, this kind of stuff. And then there's like 30 labs that go more into details. And there's 2 labs on eBPF itself as well. Yeah.
That's awesome. That's awesome. All right, let's kick it off.
Okay, so should I just...
Yeah, you can start.
Hit start.
Yeah. Oh, okay.
One thing, maybe if we could just increase the font size. I think
just
you're using a
just
map.
click on the left column and do a Control plus, and that should do it on the left. The right column, sorry, because the left is the terminal. If you click somewhere in the description, like click on like enjoy or whatever here, and then just zoom in.
There's one full screen.
Exactly. Yeah, that looks good. That was good.
This?
Yeah, that looks a little
Maybe
better.
a bit more.
Okay, because my Control
So if you, I
plus
think
is
on
not
your,
working.
try Command plus
it's
plus.
not working.
Yeah, this is good.
Awesome.
Okay.
Cool.
All right. Yeah. So this starts with, this is a cluster that only has 1 node to make it easier, because for observability we don't really need more than this. Yeah, you can execute the comments here. It actually doesn't use Cilium here, so it uses the default CNI for kind. That doesn't really matter in the case of Tetragon. And Tetragon we install in Kubernetes. It can be used outside of Kubernetes, but here we're installing it with a Helm chart, and then it installs as a daemon set. So we'll have one Tetragon per node, one Tetragon agent per node, and this Tetragon agent is responsible for reading the custom resources from Kubernetes, obviously, and configuring the eBPF programs on each node. In this case, there's only one node, so that's easy.
So there's no dependency on the Cilium CNI to make this work?
No, not at all.
Interesting. Okay, that's good to know. I actually did not know that, so I learned something new today.
Yeah.
Thank you.
There used to be a link for correlation, but this was removed. So there's no link at all.
Okay.
Right. So then we
Wow.
start deploying tracing policies. So there's the policy that is called networking.yaml. You can apply it, and we can actually look at it if you want. So you can just do a cat in the terminal or something, or a YQ on it. So we'll get colors.
Why? Oh, Sky?
Yeah, cat is good. I mean, with the networking.yaml.
Oh, wait.
So just Control C,
yeah.
and then
Second.
Yeah, so this is a very basic tracing policy, and tracing policies are essentially the control plane for Tetragon. So this is how we configure Tetragon to add visibility or enforcement. So in this case, we're adding a rule that uses kprobes, or two rules for kprobes actually, that will watch two events, TCP connect and TCP close events. And so with this applied, we'll start seeing network events and the flows that are generated by Tetragon. This is what you can see if you execute the next command, the kubectl exec that is in here. We're essentially executing into the Tetragon container, to the Tetragon pod, and looking at the logs. You can see that there's lots of logs coming out. There's default events like the process start and process exit, but there's also networking events that are happening.
Mm-hmm.
So the connect and close are networking events. So there's lots of stuff here, right? Because I mean, Kubernetes processes are constantly talking to each other, so we see a lot of events in there.
Mm-hmm. Okay.
Typically, people would use this by essentially getting the JSON events and then sending them to a SIEM. That could be Splunk, that could be Loki, that could be Elasticsearch, and then filtering there to find whatever they want in the logs.
Yeah.
So,
Oh, that's so cool.
Oh, I love it. I like that Tetragon requires Cilium. Oh, we know that's totally not true anymore. So let me ask you, who would be the primary consumers of Tetragon? Who are the people that care most about Tetragon? And how would they go about consuming it? Is it something that they would do directly, or maybe feed it into their GitOps process?
That would be mainly security teams for me. But we see people using it in very different ways. There is a big company, for example, that uses it for to observe network traffic. And the big benefit of this versus traditional solutions is that Tetragon will enrich the data in the kernel with metadata from Tetragon. So they can see all the processes that are accessing the network, and which part of the network they're accessing, and the metadata associated with them. So if it's a process on the machine, or if it's a container, or if it's a pod, that's typically the kind of thing they can be interested in. We know as well customers that use it for metrics, because Tetragon can produce metrics. So it can be network metrics, but it could be security related. You can observe things like TLS, for example, so you can know which processes and which namespaces are using TLS and which ciphers they're using. So we're using eBPF to actually parse the TLS traffic, so that it allows to quickly find which applications are using obsolete TLS ciphers, for example. So usually this is, pretty much similar to Falco, I would say. Security teams that are putting rules in place to observe and potentially to enforce traffic. To enforce rules, I think, traffic.
Okay. Yeah.
Now comes the next section.
Yeah, let's go.
Yeah, so here we're going to look at a scenario of a container escape, which uses a known vulnerability in Kubernetes. If you don't know that vulnerability, it's a good one to shine in.
So why don't you tell us what a container escape is? Because we've heard that term a lot, and there's some folks that have explained.
Yeah, well, we'll
how to
see here
mitigate it.
actually what it looks like. But the idea is that it's escaping from the container and accessing the host. Right. These days, usually if you find Duffy, my colleague Duffy, at KubeCon or at a conference, he usually has the stickers. I don't know if I have one here. I have one, but it's stuck. Was this comment that you can execute, and if your Kubernetes is not secured well enough, or if you have the right permissions in your container, in your pod, then you'll be able to access the host using NSCenter. So it plays on the Linux namespaces to do this.
Yeah, it's interesting because if you don't set like your privileges on, let's say, the pod manifest itself, the container probably can run as root, and whatever is living inside of that container, like you said, can escape and effectively have root privileges on the node itself. And if we're thinking about NSCenter, right, like every pod is a network namespace. So if you now allow this malicious resource to now enter other pods and make changes, modify the way it sends traffic outbound, it's a problem, right? So let's see this in action. Go and let's hit start. I'm excited.
So in this cluster here, we don't have rules in place to prevent this kind of attacks. It's the very basic kind cluster. So here, this first command is just looking at the events. We're going to see the events coming into Tetragon, and then in the second terminal, we're going to do the attack itself.
I like the Star Wars reference there, Sith infiltrator.
Yeah, we have a lot of Star Wars references in our labs. Dates back to this Star Wars demo that Thomas gave on Cilium back at DockerCon. So if we list the pods, you see that the pod is running. Okay, and then in terminal 1, we can actually see all the events that are related to starting this pod. We can see that Tetragon sees a lot of things there, the different processes that are executed, and every time you have the context. See in the third column, you have default/sysinfiltrator. This says that this is the sysinfiltrator pod in the default namespace.
Okay.
Right, and then you have there's an Nginx that is listening on port 80. And we can see the capabilities of the pod on every line. It has cap sysadmin, which is problematic.
Okay. Should be here. I can see Docker entry point.
The what?
I'm just finding this one.
It's all the way up.
Oh, okay.
Probably, I see JQ down there, maybe mount. Where is this? This is fine. Down there, we see the entry point executing in the middle, entry point.sh.
Mm-hmm.
And then if you go down again, we see the different scripts in the entry point executing. And then eventually this should be the Nginx.
Yeah, got it.
Yeah. So now we're going to add another rule to Tetragon to observe more things. You can have a look at it. You can do a cat on it if you want.
Yeah.
So it's again a tracing policy. And this tracing policy is specifically to observe the sys setns syscall. So we're using a syscall this time instead of a kprobe, and we're looking at the arguments. We know there's 2 arguments of type int that are used by this setns, and setns is used to change the namespace in the Linux kernel. So now if you go into the pod like this, you can actually click on the little play arrow when you go on the comment, and it actually pastes it automatically. See, if you go here,
Where?
if you go up, if you go on the comment, no, where you were, yeah, down there where you copied the comment.
This
Yeah,
one?
there's a little play to the right. Yeah, that actually runs the snippet automatically. See?
Oh, okay.
So now we're in the pod, and in this pod, so if you look in the in the terminal one, you will see the bin bash being executed in the pod, and that's what we've been seeing, the different comments. So we can see that we got a shell in this pod. This is already something we could alert on potentially. And then in there, you're going to execute the nsenter -t1, and this, because our pod has sufficient rights, it will actually put us in the namespace of the host. So now we're actually looking at the host. So we escape the container. And what happens when we type this nsenter is that quite a few namespaces are going to be set. And if you go back to terminal one, you can actually see the execution of the nsenter command. Just give me a minute.
Okay. And then, okay. I think then, yep. So I think we are good to go. So this is done, right? And this is done.
Yeah, and so you see all the result of the nsenter command, and you see on the left it says setns. So for each of these namespaces, so C group, IPC, UTS, and so on, there's been a call to set this for the process, for the pod. So this means we're now actually in the host namespace. So what's suggested here is that what an attacker would do if they have access to this is then they want to create something to make sure that they can come back, right? So to maintain foothold. And here we're going to use a known security issue in Kubernetes. If you have access to a host, then you can do something like this. You'll see if you start the challenge is that there is this directory on every node in Kubernetes, which is etc Kubernetes manifests. You know what this does, right? In etc Kubernetes manifests, you have the static manifest, and whatever you put in
static
there,
pods, right?
Exactly. Yeah.
So
whatever you put in there will be automatically created by Kubernetes, and it will bypass the traditional controllers in Kubernetes. And there's even more than this. If you create a pod in that directory and the namespace of that pod does not exist, then the pod will still be created, but it will be invisible to you, because when you do a kubectl get pods, even with -a, it will start by listing all the namespaces, and then for each namespace, look for the pods in there. But because you specified a namespace that does not exist, the pod is invisible. You can't even see it. Yeah, so this is typically what an attacker could do. So yeah, again, we can get back into in terminal 2, we can get back into the pod. Yeah,
it's interesting you brought this up, because we expect the Kubernetes API to have full visibility into what it can and cannot do. But what you just described is a very imperative approach. Like if you've got root access to a node, it's not very difficult to go specify that static pod creation, right? In fact, if you attempt the CKA, the Certified Kubernetes Administrator exam, there is, I believe, or there was a question around static pods and how to manipulate them and work with them and where they are stored. So, it's funny, because when I took the CKA, it never really occurred to me how that could be a very insecure approach, right? Like, it's a security risk or a flaw. where now you're just injecting pods that aren't even derived from something the Kubernetes API is able to see. So we're able to now even catch that. So that's cool. All right, go for it. Sorry, sidebar.
Yeah,
so now
so
because you see here, now because we're on the node, actually, you can go to etc Kubernetes manifest. That was not possible before the NS enter. So with that command, we can actually see what's on the host. So you see, we executed a shell in a pod, and then in this pod, because we had the privilege to do so, we did an NS enter into the host namespace, and now we're actually looking at the files on the host. But more than that, we can actually create a file on the host. That's what we do here with the hack latest.yaml. So this just drops a file in this directory. And what's crazy is that this file is permanent. Even if you reboot the node, the file will still be here. So even if they restart the node, the foothold, the pod we created here, will still be here. And here is just a while through sleep. It's just a waiting pod, but you could pretty much put whatever you want by specifying an image. Yeah, so you see at the top here, the pod is actually created. You actually see it with crit control PS on the node because it's a container that was created on the node, right? But then if we look in Kubernetes, we can't see it. That's the next, that's the next comment.
Yeah.
Look at this in terminal 3 exactly. We can't see it. And we can't see it because we specified a namespace that does not exist. So now in Tetragon, we can actually see that we created the file in etc Kubernetes manifest on the node. So we could have alerted on this. And that's the last step is the attacker could use this malicious pod, enter it anytime, and then execute programs on it.
So now we are into the next step, which is we are executing a malicious Python script in memory. Okay.
Yes, exactly. Yeah. So we're going to get into the pod that was created, this hack latest pod, and then execute whatever we want because this pod is invisible.
Yeah.
Yeah. So in this case here, we're using crit control to get the pod and execute into it with crit control. But potentially this pod could run whatever we want. So it could be a permanent tunnel using NC, for example, to set a permanent tunnel to a remote machine, right? So a remote attacker could come in anytime if the pod is running. So what's interesting, is that we see what's happening here in Tetragon. And we see it in the scope of the sysinfiltrator pod because we logged in the sysinfiltrator pod and then we did the crit control. So we're still in that pod.
And then
last one, this filters. So we're going to look at all the events with Tetragon and filter on processes that use either curl or Python. So comments that use either curl or Python. And then if the attacker does, so again, here we're filtering, we're using pods to do this, but again, we could send everything to, let's say, Splunk, for example, and then filter there to detect the anomalies.
And now we have downloaded that Python script.
Yeah, exactly. So the attacker could be in that container that was created and then execute a malicious script, and we could actually detect it. It takes a little while to come because of the ring buffer system in Tetragon that needs to be flushed. But once it comes, you'll see the details and you'll see exactly there you go.
Working.
So we see that this was executed in the context of the control plane. There was a curl command that was executed with that script. And we can even see the connect and close events because we added these events before. See in the middle. So in Isovalent Enterprise, we actually have an interface that is in one of the other labs in the security visibility lab, which uses the different processes that can be observed and the connection that can be observed as well, and it builds a process tree view where you can see how the processors like beget each other in some way, right? So what in a pod, what are the processes that are executed and how they relate to each other, and which of the processes in the pod actually made network requests. So you can understand what happened. If there was a pod that made a weird request outside, then you can actually understand what happened by looking at this.
Okay, so we have to do this quiz.
All right. So the first one is correct. Yeah.
Yeah.
So the tetraget events allows to actually, it ingests JSON logs, and it allows to filter them and show them in a nice way. It has events of type connect to monitor network activity. Not really. Oh yeah, no. Well, I guess this is correct. Yeah, this is correct.
Yeah, this is correct. And
No, this one is not. The third one is not. So there's no events of type Linux. But there's events of type connect. So the second one. And Tetragon events can be filtered by pod name. That is correct. That's actually one of the main points of Tetragon, is that you can filter by namespace, by pod, by labels, and so on.
So like that file name access like is one of the use case for Tetragon.
Yeah.
Yeah.
This is the one I added this morning. And the idea is, what could we do about it? So it's just one example of an enforcement policy. We could do more. So in this case, the idea is, how have we prevented the attack? There's lots of different ways. What I'm exploring here is we could have prevented from writing in etc Kubernetes manifests when we're in the pod. Even if we had the right to access the file system, we could have said, no, there's no way you're going to write to this, or even read what's in this directory. So here what we can do is, in the editor, you can look at the policy that we had. This is the last but one. The syswrite etc Kubernetes manifest. Yes. Yeah, the last but one at the bottom. Yeah. So this is the policy that we have so far. And maybe we can talk about this a bit. This is a bit complex, and that's the thing with Tetragon. The policies are a little bit complex, and as Tetragon is maturing, there's more and more abstractions that are put on top of these policies to help with writing them. But as you can see, there's still a lot of traces in there of actual kernel programming, right? So if we start at the top, we have like the API version, the kind, that's kind of obvious.
I had a question about that though. So even though Cilium isn't the dependency, it seems like all the APIs for Tetragon, Hubble, and even Cilium are the same. Is there a reason behind this, or is it just to make it easy when you're working on the enterprise side?
What do you mean the same?
So I see that Cilium.io v1 alpha 1 is also the same one that I would see as a resource in like Cilium, like the CNI itself, right? So what was the motivation behind making that specific to Cilium and not like its own API called like Tetragon or something?
Well, it was born in the Cilium project. Tetragon itself is part of the Cilium project in the CNCF. So it's considered a daughter project of Cilium.
Okay. But yeah, as we already cleared up, there isn't a necessity or requirement to have the Cilium CNI running to make this work.
Exactly. Yeah.
Yeah. Okay, cool.
What we have in this one, there's quite a few options in the spec. There's a pod selector on lines 6 to 8, which says that this policy only applies to pods that have a label org with value empire, which is the case of that this infiltrator, or I don't remember what it's called. And then the main thing is that line 12 and following is a kprobe, specification, and it uses a call called security file permission. This is file monitoring logic. with the first index, the first argument being the file structure being passed of type file. And the second one is whether this is asking for a right to read or to write the file. So we could actually filter on these arguments. We could actually prevent only write or only read by using the second argument. But here we're only using the first argument. So you see in the selector on line 20, we're using argument 0 and with the operator prefix. So anything that starts with etc Kubernetes manifest, we want to log in the first place. And then you just added an action to it, the match action, which will actually override the response to that, to the call. So whichever application is actually making that call to get file permission to read or write will get an error as a reply.
Okay, and then we update the policy.
Exactly, yeah.
And then we observe it. And then we execute the shell. Yep. Then we do.
Again, we can still access the host namespace. We haven't prevented this.
Okay.
But now you see we don't have the right to read what's in etc Kubernetes manifest. And that's without changing the rights of the files themselves on the file system, because you are still root. You still root on the machine. You still have access to the host namespace, but we've decided that this action was not allowed.
Yeah, and then we are checking the logs and oh yeah, so it's here.
Yeah, and you can see that there was an attempt to read, and the ls was actually got an error. This is number 2 after the ls minus la, which is an error.
This one?
Yes.
Yeah, so it shows 2. So like, what does 2 mean?
Yeah, so if you go back to terminal 2 and you do an ls slash, for example, you'll see what it's supposed to look like. Yeah, slash. This is still allowed. We haven't prevented this. Now, if you go back to terminal 1 and you see what it looks like, you see that you get a 0. So 0 is no error. This was returned properly. So because there's a 2, we know that there was an error in that when the function was executed. So this is pretty low level. But what you can tell is that actually, what's really interesting to me is that this was executed entirely in the kernel. So there was no user space involved in applying this policy.
Mm-hmm.
So we could write other rules. We could have just last week, I was doing a meetup where we showed an example of filtering by binary name and allowing some binaries to be executed but not others. So we could say curl is not allowed, for example, or we could even prevent the original namespace escape that allowed us to do nsenter. So we could prevent nsenter, or we could prevent the namespace change itself in the kernel.
Okay, cool. Then we move ahead. Next challenge. Final exam challenge. Okay, so they give patches as well, which is pretty
You can
nice.
do it. It's not too long.
Oh, it did come. There was. Oh, this is the final exam.
This is the exam. Yes.
Oh, okay. I thought there was another quiz.
It's not too hard.
Come on, we could get through it.
So the first task is to start inspecting the security observability event. The best way to do this is you just do Control R and find the comment that you had before. If you search for Tetra or something like this, maybe you'll find, yeah, this. See, that's the comment that we use to observe. So that's the first step.
Okay.
And then it says when you click the check button, it will send an event, and we should see this event in the logs. Yeah, see. So we have to find what events this was and put the comment and the argument in the answer.txt file, which is in the editor. So
okay.
So the answer.txt is there. Yeah, you just need to copy and paste from the logs.
And like copy.
So the comment user bin something,
User.
that was in the logs. So it's the see this the user bin cat that has been executed right in the middle.
Yes, but I like would we have to paste here? I don't
Yeah, you
see
have to
any.
paste it in the answers.yaml because this is the answer. That and the argument that comes after. Yeah, exactly.
It's still here.
Without the 0. Yeah.
Yeah.
Oh. Allow. Yep. Now this is copied and. Okay. And then
That should be
finally
it.
click the check.
Ooh, that was it.
Nice.
So this
That was
is
it.
the extent.
So why don't we kind of go back and talk about what happened there? So what actually went on in that little lab? Because it feels like we did extract some values and threw it into an answer text, but what was the intent of that?
Of the last part, the exam?
Yeah, the exam.
Well, the idea is that when you set the right tracing policy, you will see things. For example, here someone tried to read etc shadow. That shouldn't happen. So in this case, we're able to see it. We could alert on this because these logs could be sent to a SIM, and then you can do alerting. But we could even block it, like we saw before. We could say anything that tries to read in etc, for example, should not be allowed to do this, and then make exceptions.
Okay. No, that's pretty cool. So right now there's a daemon set in Kubernetes. Actually, we should be able to go back to the terminal, right? Somehow or no?
I don't think so. No, I think
Okay. No,
the
that's
VM
fine.
was destroyed.
So we have a daemon set right now deployed to all nodes, and this particular workload it's Tetragon based. It's actually inspecting the node itself for a variety of events, and we're actually implementing tracing policies to detect on these events, and when these events occur, we're taking action on them. Or doing something, or even just logging it to the terminal where we can, do some further analysis for maybe a SIEM tool of that need, like something of that nature, which is actually really cool. So is there a Tetragon CLI by chance?
Yeah, so the Tetragon CLI is pretty much what you saw. Is the Tetra command line, which allows to filter
right,
the
yeah.
events. Yeah.
Okay, yeah.
There is actually no. There's more than this. Inside the pod, there is actually a Tetragon CLI that you can use to list the policies, to add more policies, and so on. And this is typically used when you don't use Tetragon on Kubernetes, because you can actually use it on any node. Usually, you'll start it as a Docker container with privileged rights. And then obviously you can't inject CRDs, right, if you're running in Docker, because there's no Kubernetes API 7. Yeah. So instead, what you do is that you just pass it the YAML files. It's the same specifications. You just pass it the YAML files with the Tetragon add command line.
Got it. Okay, no, that's cool. And then when folks want to decide that doing this in open source isn't fun anymore, then they can come to Isovalent and be like, "Hey, give us your enterprise offering," right? Can you just maybe tell us a little bit of the differences between the open source versus the enterprise capabilities?
Yeah, there's a few things. As you saw, like file management, for example, file integrity monitoring is pretty complex. And the reason is that there's lots of ways to interact with files, right? You can open a file, you can open at if you want to seek in a position, you can do seek, you can write at, you can truncate files, you can remove files, you can do a lot of different things. So one thing that we have in the enterprise solution is that we have a file integrity monitoring system that encompasses all the possibilities of what you can do with a file to monitor it. And it goes even further because let's say I want to monitor etc shadow from the node, but it could be actually mounted inside a pod with a different name. So we have a system that actually follows this by looking at the file and which device it's located on and what is the inode of this file and tracking it wherever it's mounted in different locations. So you can actually say, I don't want any pod to read etc shadow, however name it has, whichever name it has in a different location, a different pod. That's one thing. There's the web UI I mentioned for the process tree view, which allows to actually see the different processes in a pod that have been launched and where they were launched and what network traffic came out of each process. And then there's quite a few things related to metrics as well. So like network metrics, for example. So there's quite a few things, and also timescape. Oh, I didn't have the time to actually see the whole thing. The question.
Sorry, I put it back up
Yeah.
there. I put it back up there. Yeah.
There's the integration of Timescape. Timescape is an isovalent solution that is used for Hubble and Cilium, and also for Tetragon, and it allows to historize the JSON flows so you can access them later on. So let's see, you know you had an attack 3 days ago. You want to find out what happened. You can actually use the Hubble Enterprise, the isovalent enterprise interface that we have for Hubble, and recall the events that happened 3 days ago from Timescape, and find out exactly what happened, what processes were being executed, and so on.
In one of the slides, it was mentioned that even even Hubble is not required for Tetragon, like while installation.
No, it's not required. Yes, it's not required. So in Hubble OSS, there is actually a way. I'm not sure if in OSS that you can actually put the Tetragon logs manually. In the enterprise version, we have a way using Timescape to actually put them automatically into Hubble so that we have an interface to see what's happening.
Mm-hmm.
So thinking about it from an attacker's perspective, how would I go about hiding my malicious activity from eBPF or from the kernel? Is that possible to do? It's always possible. And if so, I assume Tetragon wouldn't detect it. That depends on how Tetragon was set up. There is always a way to, well, hiding it, yes. Is that, I mean, if you have all rights on a kernel, you could deactivate eBPF functionalities on that kernel, essentially making eBPF blind. So one of the first things I would say would be, as a protector, right, of the system, is to make sure that this cannot happen. Is that an attacker wouldn't be able to deactivate kprobes, for example. Would that make Tetragon entirely blind? Well, it would make it blind until the point after this has been disabled, right? So yeah, these are things to keep in mind. This is a really good question. These are things to keep in mind. What are the blind spots for eBPF tooling? And it's typically turning off eBPF or turning off the trace points that eBPF are using, either trace points in the kernel or kprobes and so on. Container sandboxing can be used to mitigate container breakouts. Example, gvisor, kata containers, and so on. Yeah, because they will provide an extra layer of security by providing an actual kernel in between the kernel of the host and the pods. It makes it heavy.
Awesome.
Yeah.
Awesome. I was just scanning some of the other channels to see if there were any other questions, but there were not. So that was awesome. That was a great session. You know, it gave me a different view on how to handle runtime security, because I'm very accustomed to the way things happened with like Falco. And I've even seen some other tools handle some of that runtime security in different ways as well. So it's nice to see how Tetragon or Cilium Tetragon handles it. So we're at the end of our stream. So Raphael, I wanted to ask you, were there any final thoughts you wanted to share? Any projects that you're working on? Maybe things to look out for in the next little while?
No, I'm still looking into creating more labs to showcase what Tetragon and Cilium can do. No, besides that, no specific thoughts. I think it's interesting to keep an eye on what's happening. There's lots of things happening in the Tetragon project as it is maturing, because it goes from like deep down in the kernel, and there's more and more abstractions being built on top of it.
I totally agree. Yeah, keep watching this space. We definitely want to really understand where some of the security stuff is going as well, because it also increases the complexity, and there are more things that you get to play with. But then you also have to decide, like, what is the right set of tooling and approaches to make this work. Akansha, any questions on your end?
No, I'm pretty much good. Like, I understood quite a lot of things.
Awesome.
How, yeah, so pretty nice. Thank you.
See, and this is why we bring on the experts, right? Because I would just fall like on my face trying to explain this all.
The labs were like really nice. If someone wants to start with Tetragon, it's a good place to start with. So
I like that.
Vouching that.
Love that. Okay. So we will have some more streams coming up soon. I think what we're trying to do for the next one, hopefully it's going to be on Service Mesh. We'll try to bring one of my fellow Canadians, Christine Kim, if she's available. If she's also watching this, maybe, she'll reach back out to us. But we hope to have her on. And then if you are operating Cilium in production and you're happy to hop on a stream with us, come on board, reach out to us. We'd love to hear your thoughts on how you've used Cilium, how you've scaled it, and some of the constraints and challenges that you've worked through, and maybe even how you got around that. And yeah, we're looking forward to hearing more and more of those stories as well. So again, thank you everyone for coming by today. We hope you have a fantastic Monday, a fantastic rest of your week, and wish you all a good morning, good afternoon, good evening, and good night, everyone. Take care. Raphael, thank you so much for coming by.
Thank you.
And Akansha, thank you for being a guest, a host again. Take care, everyone. See ya.
Bye.
Bye.